So just to introduce, like Chetan and myself, we are going to like take a series of uh, sessions on mostly workshops on like teaching machine learning, help you learn machine learning. And to tell about Chetan, he is a HBase contributor and a Apache Spark contributor, and like he's also an international speaker. And about me, there's nothing much. So I'm just saying something since 29 years. So the whole idea of machine learning is about today's event is about explaining, giving you the meat of what you will be learning in the further sessions, the future sessions. Okay, and this is going to be pretty much a wine tasting session. You'll not get high, just that you want to just taste some wine today. And you can always walk up to Chetan, and you can find him in beta, and you'll not find me maybe from tomorrow. So tomorrow is my last day here. So what's machine learning is the machine that learns, right? It's pretty straightforward with that. So here, it is a subfield of artificial intelligence. So they have to put a clear distinction between, there's a lot of things between like having a data science, there's a confusion of having data science, machine learning, and there's no clear definition. So to put in perspective, data science is a field where you have a lot of data and you're trying to make some sense out of it. You just try to extract some meaning out of it, which is useful for developing the business or other. Say for example, it could be mostly you can find like statistics and all these things coming into the picture of the scene. In terms of machine learning, and that's probably like your everyday thing. You find it in your recommendation engine, like your Amazon, or probably even like you go around like self-driving cars. Self-driving cars are like a little extended version of machine learning, which is deep learning. And probably I think it's probably everywhere. But like, how do we relate machine learning to yourself, right? It's just not only part of the career. It's just probably a reflection of yourself. So imagine this: we all have some contacts who always keep sending, forward messages or like some crappy jokes and everything, right? So we like over a period of time, when you see all these messages, we kind of get used to this. This guy is just spamming, and like you do not really give that attention to that person's messages, right? It's just that like we have learned from it over time. Like we know that this person, he does not send important. This is one of the features that you kind of understand from the whole machine learning perspective. So the same thing that you are trying to teach a machine in the sense of software, that these are the features you have to look for. So when there is a data, or when there is a question in the future, then it's going to predict. It could be like, so the same example can be applied for a spam. A spam can be as simple as a name-based classification, which is a classification technique, but very fundamental, and it's very effective. And you can see all these professional grade spam filtering techniques like spam-base and things, which still work on name-base and a little modified version of name-base. So explaining about like kind of machine learnings we have. We have supervised machine learning, which we tell the machine, we teach the machine that these are the things. So just for example, I think you might see this example again. It's just that like you probably have to differentiate between an apple and an orange. You tell the machine like probably the first thing you might have to see is a texture of your fruit. If it's like if it looks nice and fine, then it's probably an apple. And if it has this bumpy texture, then it's an orange. Or it could be something of a weight. If you see that your orange is usually like orange is more heavier than an apple. So these are some features you extracted. Then this is one of the steps of your own training data. So you have a training data, then you have a test data. You use your training data to train your machine, then you have your test data to test that. Yeah.
Yeah, so as we talked earlier, like artificial intelligence and machine learning, data science, and data mining can be a separate subject, can be joint of that. When I learned ML plus data science, big data, and the data mining, I learned first algorithm, then I was not aware with that. It can be distributed, it can be parallelized, uh, it can predict something that can make as a service. So now the way world is changing, it's not only transforming the IT industry, it is transforming the all automotive industry. So the artificial intelligence is not just going to replace the humans' ability that can just test, but it can also replace the humans' ability to take decision on the train data and the test data. So as we have seen earlier in the 12 March 2016, at that time, simple chess game can be trained on the computer, but the Chinese AlphaGo game, which is a very complex pretty much game that to take a lot of decisions on top of that, that you can see over here, the agent created by DeepMind, acquired by Google, that used to win 3 times as versus the champion of the Go game, Lee Sedol. So it's the transformation and the revolution in the all the industry happening right now. So as Shabinesh explained the branches of, so we would say mainly we can create the 4 branch of machine learning. One is supervised learning, other is unsupervised learning. Third one is reinforcement learning, and there can be branch of deep learning over here. So I say supervised learning, you have the trained data and test data. So the trained data should be labeled. It has the independent variable and the dependent variable. When I say label, it says that these independent variables depend on that. It creates the clear correlation between all the variables. And unsupervised learning, there's not all the test data is not labeled data. So it can be it can be used to solve the unsupervised learning problems like clustering. And supervised learning can be used into the deep learning to solve the problem. Reinforcement learning, that is a separate branch of machine learning that takes decision based on the agent. Agent takes reward the step taken by agent. So if I say there is dog, you want to train to your dog that take the step. But if dog is doing something wrong, you will give punishment. So that punishment is known as a reward to agent. So agent will get to learn from that all the rewards and take the steps. So AlphaGo is based on that. One of the algorithms known as Monte Carlo tree plus the deep learning and the recursive network that created under that with that agent. So in general, it can be, machine learning can be applied on the computer vision, can be on speech, can be on any kind of unstructured structured data that you want to learn. And you can train your model on top of the computer vision like images. And that pre-trained model can be used as a transfer learning on the type of, like you have the voice, you try to pre-train that model and transfer that model. It can use to create the image. So this type of model known as a GAN, generalized utilized network model, that used to create the images and try to make that fake images and generate to combine with the correct image. It can also draw the image. There's one of the project in Stanford known as a Deep Dream, created by the unsupervised learning technique plus the supervised learning technique. So it's not only that you train model, you predict something, but you can, so there's 2 things in machine learning, is a training and inference. training means training takes a lot of time. It requires good high performance machine also to train, because it does the same iteration again and again. So when you have same type of data and you try to make reiteration again and again, that model will try to understand better than other data. So once you think you apply all the algorithm and you think that model is having good accuracy, there's less error rate, you make it pre-trained model and you do inference. So inference would not require much more good high performance machine. You can also port your pre-trained model on embedded device like smartphone, and you do that same thing. So application of machine learning, I would say it can be applied on vision, it can be applied on the NLP, it can be applied on speech, it can be applied on conversational or conversational dialogue agent, because a chatbot is just agent. So this conversational dialogue agent use the purposes of the dictionary. Like you have dictionary, the same data. So people use library called NLTK or Gensim to use the different type of corpus and train the model in between that. Yeah, so you might be thinking what can be done with machine learning. So simple, you give image, which can not be understood by humans sometimes, whether this is a dog or cat. So first you provide the trained data. So one of the famous data set of the image is ImageNet competition, started from 2008, and people like Karpathy and Somit Sintal are working on the ImageNet from the Facebook or Google Brain. So it takes all the pixel. So when I say what this image means, this image is the n-dimensional matrices. And machine learning is all about matrices and vector. And vector and matrices are the primary data set of the machine learning. So you might be thinking why you require graphics card when you want to play the games. Because when you do operation on top of the matrices and vectors, it requires graphics card, which has the block size and everything.
Yes, sorry to interrupt you, Chetan. So this is Kuldeep here. So we are from this Calcutta office, and we request you to take down your this webcam so that we can see down the people.
Yeah, just a minute.
Okay.
This is Zoom application, yeah? Zoom application.
Come down. No. Yeah.
This is this presentation. This is this too. अभी इसको presentation कैसे करूँ?
Is there?
Can you see this thing?
But it's not something we want to depend on.
Yeah, so as I said earlier, so if you know the biological network architecture, which has the axion and synapses, same as the same formula can be trained on the any programming language, like people use Julia to Python to R, or the Scala, any functional language that can, or the imperative paradigm can support the both things. So usually in machine learning, people use the imperative paradigm and the symbolic paradigm. So this, as I told earlier, this is this image is nothing but the 4-dimensional or n-dimensional matrices. So this all the matrices number will go over here, and it applies the activation layer and the activation function like cross entropy or any other function that can train on that. We are just talking about fundamental thing right now. Yeah, so it, as Shabinesh discussed earlier, what kind of problem can be solved with machine learning? For example, whether you want to predict whether this, or classify whether this is apple or orange. First, without machine learning, you will say, use the like any programming language like Python, or grab all the pixels. If pixels range on this image is red or green or orange, then we'll say this is orange or this is apple. But if I change the color to be a scale, then that function will not work. So ideally, you will say the pattern is plain or bumpy. It's bumpy, then you will go with the um, apple or the orange. That can be so. This all the features like bumpy, weight, or the color or pixel that can be your train data. And when I say label, it's apple or orange or like that. So this kind of when you can programming language and say 5 conditions like control structure or if else or switch case, it's okay. But when I say apply 5,000 conditions, which is not possible, and it can be possible once, but it cannot be possible to everyone. So when you have multiple conditions, it's not possible to write 500 conditions if else. But you try any algorithm like regression or the XGBoost or whatever it is, that learns from the internal patterns of the trained data and find the correlation from the data. So whenever you use the data, you use the either sparse matrix or dense matrix or the tensor. So it would be easy for any Python package or any programming language to find the correlation between the numbers. So ultimately it will be a matrices or the vector. That can be fine. And if you say, what about a dog or a mop? Okay. So it's okay, you can guess right now it's dog and it's mop. But later, if the question is like that, like dog by Facebook dog or Zuckerberg dog, which has like that, sometimes it's not possible for a human to characterize whether it's a dog or mop, right? So when you have a lot of images of the dog or the mop, so your machine learning algorithm can identify whether it's mop or dog. So what can be done by machine learning in a vision? So in computer vision, you can whether it's a lion or leopard, you can detect the face over here. Maybe in Facebook, when you upload an image, when it used to tag you, right? Same thing can be done over here. In OCR, you can see optical character readers or find the characters from that. It can also explicit content detection. Sometimes you have old photos taken by earlier mobile phones, the smartphone or HD. You want to clear it out, it can be possible. Landmark detection, you upload this and it will say, what is this? And you have something icon or in the picture by company logo, it will identify this is logo by Google. Next.
So
When
this is a part of structured learning or unstructured learning?
So images is known as unstructured data. I mean, by image you cannot identify structured data. Structured data means like this is structure like spreadsheet or the RDBMS or like that. Unstructured data like Word file, PDF file. You cannot get the structure. But when you feed this model to machine learning, it will be just numbers, matrices and the vector, which is the number. So ultimately the image will transfer to pixel. We start 0 to 255, which is number. And machine learning only understand the encoding technique. It won't, I mean, you need to first pre-process the data. So when you pre-process the data, you need to convert auto encode to the matrices of the vector, which can support.
Okay. In the case of sound, this is all images, but sound also.
Yeah.
It converts to numbers.
Yeah, obviously, because computer can understand 0 and 1 from the transistors. So when you convert anything, you can convert anything to 0 and 1 or the in pixel is 0 and 1. So there are autoencoder and decoder techniques different, like to compress, like we have Hellman technique to compress the files, SMS to encode and decode. We have some techniques to use that.
So,
But we just care like this method is required, this type of data. So you need to convert that to matrices and vectors.
so does it require any kind of hardware knowledge?
No, you don't require any hardware knowledge, but obviously you should be in prerequisites that your machine has a good configuration. At least it supports the like VI or like that in your BIOS, so that virtual things can realize in between if you require. So for training, you require that thing. For inference, you don't require the high config machine.
So I want to compare an image with some voice. Does it happen with that?
Yeah, so first you need to provide the voice data set, image data set. Like you say you have a voice by something is Shah Rukh Khan. And once you provide that MP3, it can retrieve all the images of Shah Rukh Khan. Like that.
In case of when we are trying to train the machine, so in that scenario we had Google goggles that was provided by Google. So whatever you scan, it will try to identify meaning out of that image.
Exactly. So the Google Cloud Service is exposed by Google Cloud API. So that's a pre-trained model. It's trained on top of the Google Net 2014, right?
Yeah.
So that Google Net 2014 is a part of deep learning. Okay. So they have one GPU cloud inference, right? So they can expose and they can analyze. Once they train their model, they will make it service, right? So all the startup can consume that API and just say like JavaScript dot something image, it will say what it is, right? So that is known as the inference.
Okay. So they would have trained that machine by providing so many images.
Yeah, this data has known as an ImageNet, and that is the, I think in 2014 that team Google then was led by Andrew and now Dr. Khatri at Stanford, and they have trained this model. So this picture is not clear, right? So if you input this picture to any deep learning model, it can clear your picture, make it like whatever background noise it has in image, it can clear out all the noise and give you the clear picture. So that can be done with the machine learning. For example, I'm talking about transfer learning. When I'm talking with Skype with Manas, at that time there are background noise coming from all the people. So I made the one machine learning model that removed the all noise. Same model if I'm using on the image to remove the noise, right? That is known as a transfer learning. And that transfer learning can have all the hyperparameters, right? Like how deep it is. That we'll talk in technical session later. But those hyperparameters can be changed and make it as a transfer learning. For example, sometimes you take pictures which has a grid over there, and you say it's not clear. I cannot print it out. But you can use machine learning to remove the noise. So this is how it looks after applying the machine learning. So when I went to Pondicherry last time, so I captured. So actually, I went to Aeroville. Over there, it was under construction, so I cannot take picture of Aeroville, that small statue. So I took picture outside, and that picture, when I applied this model, clear out like this. And it can be used in a, like when your kid want to create some art, it suggests do you mean this icon or not? So when you create the art, it tracks your pointers on your pad. According to that, it will suggest do you mean this or what? So ideally, when you train model, it takes all the edges, vertices, and everything inside the model and would like to suggest what does it mean. And initially, when you do training, at that time, you also provide the three types of data set. It's not train and test, but a cross-validation. So cross-validation data set is used to decrease the error rate. And this optimizer automatically test that if error rate coming low, then optimizer will decrease some or adjust the weight and bias in the model and change the parameters. Yeah, it will suggest that do you mean this, and automatically it will create the same icon. Yeah, so earlier business model was everybody talk about cloud, mobile, analytics, but now without AI, I don't think, I haven't seen any product without AI which works. Like when you search in Google, the result you get is personalized for you. When I search on Amazon, the result I get is personalized for me. So obviously cookies playing biggest role in that, but there are other ways in the machine learning that suggest you something. So for example, if I'm taking image of this, it will say this is the this talk is, you want to get ticket, you say, yeah, get ticket. It will save the event over here for you. So I think everybody has a lot of applications in mobile, but obviously within 2 years or 3 years, you will have same application which can does everything for you. You order pizza from the same application, it will save your credit card and do payment from that. You don't have to go with the Paytm to order something and do something. The same application can do everything. So user, sorry, can you move this panel down? No. In that last one. And just check. Thank you. So as I said earlier, user interaction model is fundamentally changes. All the product applies machine learning and deep learning at all, right? And the big tech companies like Facebook and Google are trying to learn from you because you are having intelligence, right? Wherever you do something that captures your experience. So as Shabinesh said earlier, machine learning learns from the experience and the examples. So experience is what you people provide to Google and Facebook. That's how you use most Facebook and Google. It creates more accurate model for you only. Yeah, so if you capture the photo of the Wills Tower, it will say Wills Tower is, it will automatically say Wills Tower Wikipedia page. You can get the direction to map and you can call the contact number available in the Wikipedia. And if you go to any museum and capture the photo, it will say what does it mean. Because if I'm going to France, I don't know this language or this photo or what does it mean in museums. I just capture the photo and I get to know in English what does it mean. So if you compose the email and you select the something string, if it's adverse, it will direct you like it's a map. You go to map and directly you can say you can give the data connection to the destination from that. So the email body content, the known as a NLP, can be applied over here, and unstructured data can be known as NER, named entity recognition, or the POS, part of speech. So from here, that application is going to recognize the phone number and directly showing you you can call from here. If you say the email account, it say you can Gmail from here, and like that. So ultimately, machine learning is helping to company to provide it as a service and create the product. So, yeah. In the form of language understanding, when you provide a string, it will say, this is a noun, this is the adverb, or this is a dependency, this is a lemma. Lemma means the plural of the, sorry, it's a verb of any word. So when I say help, it's provide help over here. So based on that, if you use your keypad in Google, it suggests you something. Then you say I, you say am, or like that. So in your mobile, the inference does on your experience, right? And Google is very smart. It directly hit internet to your the training model, and it will again provide the specific inference to your mobile. Yeah, other application is known as a sentiment analysis. So if somebody is tweeting or Facebook feed or like that, so that is a string, right? It can be positive, it can be negative. So if someone creates the model that classify whether it's positive or negative, like in this string, I really like the sushi, but service was terrible. So you can't say by simply that by any simple kind of structure that whether it's positive or negative. It says for the sushi, it was the score sentiment is a positive 0.8, but for service is a bad minus 0.9. So in accuracy in machine learning is predicted in between 0.0 to 1. It's not on percentage. So it's 0.9 equal to 90%. So use cases, a lot of use cases are there. So what I know I have mentioned over here. So first use case is a recommendation that I told earlier, like The recommendation can be used to personalize the user experience. It's not the same static website. You provide some content visible to everyone as it is, but recommendation can provide the what your customer behavior want, what actually I want that can give the user experience. NLP is understanding the language, and the financial trading, it can predict the stock market. If your experience is like that, it can predict for you. In marketing and sales, it can target the audience. Like I worked with the ICICI Lombard, over there I had data of the customer. They want to predict that whether this customer will take loan or not, based on salary, based on destination, based on the paid amount, based on transactions. So all these features are as the train data for the machine learning algorithm. And when I say 0 and 1, there's a classifier which will predict whether it will be 0 or 1. So whether the customer will take loan or not. If customer will take loan, it will be 1, if not 0. So those data sets will be provided to any sales department. So sales department will call on those people. Same as like if in the HR department is coming like resumes of the people. So it will pass the unstructured data from the PDF. It goes to LinkedIn. It goes to other data, and find if any fraud is there. Like if any date applied in the resume is not as actual, we'll get to find all there. And the healthcare, as you have seen in the January 2017 by Stanford, they have classified predicting the cancer detection from the images. So same thing, you can try to predict the accuracy of the sequence of DNA. So you will get to know by genetic or once you get the accuracy on DNA, you will get to know whether the patient has a genetic problem in some kind of disease. So you can help patient to diagnostic or treatment by sequence of DNA. Sentiment analysis is to understand the customer view on the product. Self-driving car to avoid the accident due to the driver mistake. I think people will say after 10 years or 5 years that earlier people were made to give car to human, which can make the mistake. So you can detect the object, as I told earlier, from image, whether it's car or dog or cat. And the object segmentation. So there is model known as image description. So that model will describe about the image, what's going on. If I capture this photo, it will say this is conference hall, this much of people are there, or like that. So that can help. Like if I'm sitting at home, I have some like shopping mall outside. If that pretend model is there, it will give me the count of people in a queue. So when the count of people are less than 10, it will raise the alarm. So I will go over there and do shopping. If the count of people are more, it will not raise the alarm. And the dialogue agent, as I said, question and answer from the specific branch of purpose. And you can do also fraud detection. Yeah, so people may be thinking the difference between machine learning and data analytics and the life cycle difference. So in the business or in the product-based company, the having only understanding of the machine learning cannot help. If you don't understand the business, if you don't understand the correlationship between your data set, your current model will get overfit or underfit. Underfit or overfit means when you have model which is giving high accuracy on your trained data, but when you do inference, at the same time it goes down, that does mean model is underfitted or overfitted. So the data analytics life cycle, you understand the business, you understand the data, you cleanse the data, you do analytics on data and find the correlationship between the columns in Excel sheet, for example, and predict the data and visualize the data. Sometimes visualization can help you finding the correlations between all the variables. And then you build the insight that helps to grow your business revenue. And then you have to explain that everything to your executive, like CXO. And then CXO people will take the decision, and hence you can increase the revenue. So in machine learning, the life cycle are very simple. You do data quality, that's a DQ. Feature engineering. Feature engineering means you should not use all the variables. There you can find by visualization that some of the columns are not tightly coupled with the independent variable. And you find that if there is a timestamp, you create timestamp to number of the minute, hours, seconds, and weekday, or like that. So how you do simplification of your data set, how fast it works and how fast it provides to you the prediction. So then you need to choose the model, best model for your data. It cannot be possible like one shot by checking the data you can say this model will work very well unless you understand data very well. So you start from a regression and you go to deep learning, RNN or CNN if required. And sometimes like ensemble model can help you to increase the accuracy. At the computation level, you might think if your accuracy is 0.885, you want 0.89. So at the same time, you do ensemble the model, like use the regression, get the prediction, use the XGBoost or any tree-based algorithm like random forest, and you say this plus this plus this divided by 3. Or you can use the K factor, that's known as a K-fold. So you do folding out your trained data set to number of data sets, like K means 5. So what will happen, first section will be your train, remaining 4 will be test data. SM, second will be train, and first and remaining 3 will be test data set. As you do cross validation or the K-fold, it will help you to ensemble the model. So there are two types of ensembling, and then you need to tune the hyperparameters if you're using fit-in model. And there are techniques to compress the model, hence you can port it to embedded device. So all the matrices and vectors can be specified or synced or break or quantized to port that model to embedded device. So in tools and technology, I think primarily people are working with SAS, SAS, then they people move to R, then Python. Yeah, so Python has all the wrapper to every binding to C++ library. So ideally, people more prefer C++ and Python to create the modeling. But when you want to inference or use the written model, people use the Python more. It can support, I think, Ubuntu, Windows, Mac, and Android. So ideally, in the machine learning, people use the symbolic paradigm and the embedded paradigm. Functional paradigm is not mostly used. Functional paradigm people use when they have to do data processing or clean the data mostly. So libraries are huge libraries. Every company create one library. Facebook create PyTorch, Google create TensorFlow, Baidu create Pebble, and also the Cafe 2 by the Montreal. And also academia is doing tightly coupled integration with the industry, like Joshua Bengio from Canada and Montreal, and Geoffrey Hinton from Google and joined to academia and trying to train more and more scientists at the academia. So tightly coupled integration and try to just create the integration between academia and industry. They try to remove the gap between industry and academia because ultimately the funding and everything comes to lab from the companies. So this library, people start NumPy for the applying operation on the matrices and vectors. Pandas to do data manipulation, like people have the flat file or any filing, you try to clean some data or change the structure of data, that can be done with Pandas. Scikit-learn has all the packages for all the algorithms mostly. But scikit-learn should require data on same node. You cannot parallelize the data. So if you want to say same algorithm while training you want 6 nodes or parallelize that, you cannot do with scikit-learn because scikit-learn requires data should be on same node, whether it's trained data or the test data. Seaborn can help you to visualize the data. Matplotlib is the all library working with the data visualization. If you want to do specifically image processing in the Python, there is a scikit image. And these are most famous deep learning library from TensorFlow and Caffe and Theano, Torch, CNTK. So most of the libraries are in Python, apart from the deep learning folder in Java. And the Torch support the library language called Lua. And Trainer is from the Intel. MXNet is from Amazon. So nowadays, TensorFlow and MXNet provides all the wrapper for all the programming languages from Go to Java to Python, everything. And up to this, you can use the single machine. But when you want to do parallelize, you need graphics card or GPU. So GPU, or people use TPU right now, tensor per some unit. So at that time, it requires the CUDA library. So CUDA has a TensorRT, DeepStream, and the linear algebra library from cuBLAS. That are all the technology that can require to do end-to-end from fundamental production machine learning project. And Keras is one of the famous wrapper on TensorFlow. So TensorFlow you can use as a backend with Theano and also Keras. So Keras has the directly pipeline or the plugin with the TensorFlow. So you can import only Keras and play with TensorFlow. Setuping this everything requires some kind of trick or hack. Or you can use the pretend image from the Docker and pull that image and play with that. Next. So thought process in machine learning, it can be training and inference. So training, you do forward and backward. But the inference, you only do the forward. You cannot come back because it's faster inference. And it won't have much more control structure in the training, but inference, it just gives you the outcome. Yes, over to Shabinesh.
Who felt it like a heavy metal concert, something of that sort? But now it's too heavy for, like we actually intended to keep it really, really simple and not to scare you. But I just want to kind of give some advices on like how to learn and what to learn. And how many of you came here today that you learn machine learning? That's something in a day. Probably you're wrong. So one thing for me, I personally find, like I've spoken to certain people here, and actually a few of my friends who came and said where to start and how to learn. So one thing I see is a FUD. The FUD is fear, uncertainty, and doubt. So for example, a Java developer who's like 10 years of experience, who does not want to venture into a newer place just because they may become a fisher. I think she smiles. I think she agrees. So they don't want to move. So I call them fudders, or personally.
What is FUD?
Fear, uncertainty, and doubt. So I have this practice of, this is like something, these are some techniques I follow that to my own things, but it's something that should be tuned personally to yourself. One of the things is the 30-day challenge. It could be something for me. I kind of keep taking 30-day challenges, whether it's like doing yoga every day or like cooking for myself for 30 days, a challenge. So it's also about the studies. You kind of go about like learning some libraries and like sticking to one thing for a longer term, so that you kind of get some picture out of it. Because we kind of keep changing over and over again to different things, keep trying, which is easy, right? With respect to machine learning, there's nothing called book. Like you have to go around, check out data, and data is not all the same all the time. It is always different, and you will not even find probably all those libraries in this previous slide. It may not be even enough for that. You have to go see the data, and it is so much a variety, and you have to probably like go hands-on and start working on that. So another thing is that the libraries, there are like amazing amount of libraries which has enormous capability. But if you don't understand what models to apply, ultimately the whole machine learning or even data science, whether it's you have the data and you want to train, but the whole challenge is finding the model which will fit in, or so because your data could be of different, it could be n-dimensional or something. So you have to find that model, right? So you have to kind of get that math. I'm going to come what is the fundamentals for that math in the next slides. Other thing I do is writing blogs. Writing blogs is not for others, but for yourself, for your own understanding. You get write blogs and you have much better insight into all these things. And they're like in Bangalore, they're like meetup groups. There are a couple of meetup groups that are very active on machine learning and data science. And actually, there's a lot more meetup groups on very specific libraries as well. Something on deep learning, on TensorFlows, and all these things. Conferences, there are like not many conferences in Bangalore. There's one conference called Fifth Elephant. Though it's like a little bit pretty expensive, but it's worth it. But you can actually find some more conferences abroad. So a lot of reading code from others is pretty important in terms of you cannot like go figuring out yourself everything. You just have to learn sometimes. Being smart is go check out other people's code. I talk about mathematics here. These are the fundamentals. I know you have probably studied all these things, but these are very much required. At least your fundamentals are required. Most of your models are still linear algebra. You still have matrices. You have to talk about vectors. So one of the things what Chetan didn't show is there's also complicated equations. Though they might sound simple, but it's a lot of complicated equations. Even if you want to read the complicated equation, you have to have these fundamentals with you. And probability, calculus is something I wanted to put it here because most of your integral symbols, if you don't know what's an integration, then you will not be able to read the equation itself. That's the good news. It's not that you cannot become. It will take a longer time to be a machine learning engineer. It could be a pretty short path as well. So I kind of devised this syllabus to be a minimalistic learning. So first thing for me, first thing for anyone is to pick a language. I would suggest Python or R because Python has like amazing amount of batteries which are coming in, and even R is very specific, and you can actually find all these algorithms already coming out of the box. And R has a very broad range of batteries included. Data analysis. So I told you like this is a little bit kind of there is a segregation between machine learning and data analysis, but without data analysis, you will never understand your data, and without understanding your data, you can never train your machine. So data analysis is again required. So NumPy and Pandas. NumPy is the raw matrix library that you will probably be using to create all your n-dimensional matrices. And Pandas is another very important library that you can just create tables and those are that. Unless you see your data coming into the screen with some design patterns and all these things, then you will never be encouraged to do anything. So data visualization, you have to visualize your data. Only by visualizing, you may get much more insight into the data. And I personally use like Matplot, and if you're going for R, I don't use that. And you need to have statistics. These are like some important like links which you can probably note down when it's published. So there are other courses in Coursera for statistics. You can like it's usually like a 6 weeks course or something. You can just go pick it up. And finally, it's the whole challenge comes here is to learn building models, and the whole idea of machine learning and to be a machine learning engineer is actually to learn algorithms which can learn data, right? Learn experiences. So these are the very fundamental pieces of those things that you might learn to actually call yourself an entry-level machine learning engineer. So I told you, and these are like pretty fundamentals, and from here they're like branches out into very complicated and customized models, and they have different names. But don't be panicked. These are very straightforward. You can just go learn it. And these are the resources. Kaggle is a platform where you have data and you have competitions. You can go take part in the hackathons where you can go work with them to actually like uh, do the machine learning. Since they provide the platform, they also provide the data, and that's pretty amazing. And Udacity has multiple machine learning courses, and one of them which also teaches you Python, and I think is build your own self-driving car. So that's another one. And Coursera has like multiple, and all of these. I mean, you can just take note of these links or when it's published. So I have this timeline. If you can learn machine learning in 6 months, and that's probably probably brilliant. But just for an average person like me, I've done a plan for myself, which is 1 year plan. So the first month I usually like go for I pick a language. That's the first thing, right? So even if you know a language already, meaning other than Python, I think even in Java there's a library in them. So you can just stick to that same library. It's not a problem. And data analysis and linear algebra. So these I feel should go hand in hand, and you should keep practicing again. Like only, I mean, like when you learn linear algebra and data analysis together, you have much more clarity of what you're learning at all. And I mean, I put together data visualization, probability, and distribution and practice together. And statistics, algorithms, what I told you in the 10th month. And this is like the practice is what makes it perfect. Yeah, so for the last thing is before you come for the next session, which will be done by Chetan, these are some prerequisites that if it's I mean, there's no allergy for Windows, but if it's a Linux, it is great that someone can help you. And most of the libraries in Python are so. This whole of these sessions will be in Python. We recommend 2.7, though Python is currently like 3.6. All these libraries, which we told you, are like very very stable in 2.7, and that's what is recommended. Linear algebra and calculus. You can put. I mean, I can give you later on some links on where you can basically there's some YouTube videos which tell you talk about linear algebra and calculus as well, and learn some Python, and I mean that's about it. I mean, if you can go to analogies, there's like amazing amount of practice books which you can go and practice. And this other the project Euler. So when you go to you can just go to Project Euler and like start. There are like a lot of problems for your own practice, language practice. That's about it. Thank you very much.
Yes, apart from that, the plan is like that it will be 1 month boot camp over here. So we want, if someone want to speak in this month, I think we have 2 slot entry in 2nd and 3rd week, or it may be 3rd week is empty slot. So they can contact me or Hemali later with the title and what they want to present. So goal is like that. Second session we want to try to teach on linear algebra and calculus with Python, or hack mathematics with the Python or like that. Third talk will be on all the statistical APIs with the different predictive models on data set, sample data set. And fourth talk will talk about Keras and TensorFlow as a backend. So you have some images, and you will be getting the image, you predict model and inference on like pattern model, and get to know whether the image is which kind of emotion like that. You predict the segment or object from the image. This is the entire plan, rough plan. So that's what we are looking for. If someone can speak on 2 slots, that would be great. Thanks.
So,
yeah, we'll be sharing the YouTube and the
PPT as well. I'll share it with them.
So is Mac allowed? It says no more render in Linux. So Mac should be.
yeah,
Sure, that's fine.
fine. The kernel is same, right?